So I hope you can see the P&ID right now.
Hello.
Yes, I can. I have a copy.
Okay. Good. So the legend sheet is nothing but it gave an information, the details information we are going to use on our P&ID, on both P&ID and PFD. The last time we treated the PFD and the P&ID as well, but we're supposed to start with the legend sheet before we move on to that one. So today we are going back to the legend sheet properly. So the legend sheet will contain all information we need on our both PFD and P&ID. In terms of the equipment, in terms of the instruments, and the numbering patterns, the instruments, and so on and so forth. So, as I said, each company has its own different legend sheet. The legend sheet of company A will now be the same. That is the symbolic representation of the drawings. Either the fittings are not the same. So what I mean by fittings, the fittings there are just the equipment we use to connect the flow lines, which include when we say fittings, they include the flange. So I believe most of us are familiar with all those fittings, like flange, like the elbows, like reducers. And the reducers tools can either be eccentric or concentric. So as time goes on, we'll be able to differentiate them with respect to their drawings. So looking back, looking at the first part by our left-hand side, you see the instrument letter identifications from A to Z. From the first column is a variables we have there. And the second columns of it, we have the modifiers and the function as the third column. The next column, which is the response, which is the output, the response to the variables, that is the response to the variable, and the modifiers as well as the last part. So A, we have analyzers. So we have burners, we have users up to the Z, which is the positions. So, but as I said, as time goes on, meaning the fact that we are running under a short of time, as time goes on, when we reach the P&ID, we'll be going back, we're making reference to it, but just familiar with them. Then moving on to the next, we have the instrument symbols there, which we have as the first one, we have a local mounted, which is field, being represented with a circle. So what we mean by the local field here, there are some instruments you mount on your equipment or your flow lines that you just have to go there and take the reading directly with the help of either your pen or with the help of your pen and your what and your papers. You can go there to take the measurements such as pressure, like a pressure gauge. You mount it on the flow line to measure the pressure within the flow lines. So you go there with your pens to just look at it from the screen and take the exact pressure or the temperatures there. So they are field mounted. So the second one we have there, which is circle with a line drawn, not auxiliary, it's just horizontal. With horizontal line drawn in between, is front panel mounted. Front panel mounted, they are HMI. What do we mean by HMI here? They are human machine interface. They are in control room. They are in control room that displays on the panels of those instruments you have there. I mean, the dash, just like a dashboard of vehicles. So you see there also mounted around the HMI. That is the within the control panel in the control room. So the next one we have local panel mounted. So local panel mounted is still reference to the first ones of local mounted, but this one is you go there, it's also display. It display making reference to the control room, but you can go there as well, take the readings. The next one we have the back panel, as I said, is inaccessible, but is at the back of the control, is in also the panel of the control room is also cited in the HMI of your control, but is inaccessible by the operators. Is at the back of the equipment there. So we have another one, which is a circle with dotted enclosed with a box. It's a sharp display function not normally accessible also by the operator. It's not normally accessible, but it's also there, just like the first one that is not accessible. But this one now, it will now transmit. The first one is there, that is the first one with circle with dot, is there at the panel of the, but it's inaccessible. So it's also there, it's just recording, but it's not displaying. It's not, I mean, it's not sending it out. But the second one is display and as well transmits to either to the field, if you are in the field, for you to see it. It's not accessible by you, but it's there. So the second one, the next one, we have a sharp display function normally accessible to the operators. That one too, this one is accessible, unlike the first, unlike the upper one. Then the next one, we have a sharply display function, is what? A remote location. Then we have a logic, and we have another one to this side. We have instrument sharpening, instrument sharing. Then we also have a pilot. So all those ones, they are instruments we mount on our flow lines and as well as of our equipment. But by the time we move to the P&ID, we'll explain them in details for us to understand. No. Okay. So now we have a series of valves there. Our valves, there are many. In oil and gas, or in general, we have a lot of valves and at the same time, difference in functions. The first one, we have bulb valves. As I said, if you check the legend sheets of another company, the way they are represent their the legend sheet, or at the same time the drawing might not be the same symbols for another company B. Company C might not have the same, but at the end of the day, they are all tending towards the same symbols. So if you understand the A symbol, it will be very easy for you to understand the B symbols. So if you are working in company A and you shift to company B or shift to company C, once you're familiar with company A, it will just be a little or a minor differences. So now, looking at the bulb valves of the first one, we have a bulb valves there. So the bulb valve sometimes is always represented like if you look down the fifth or the sixth after the diaphragm valve, if you look at the globe valve we have there now. The globe valve is the way we represent the globe valve is the same way we represent our bulb valves. But the difference between the globe valve and the bulb valve, the globe, there is a circle shaded in between. If you look at it, you see that circle is shaded. But if it's a globe valve, if it's a bulb valve, the bulb will not be shaded. It will just be an ordinary bulb. They will put a bulb without shaded. That is the major differences between the bulb valve and the globe valve. So the next one, we have a butterfly valve. Then the next one, we have a check valve. So we have the next one check, we have diaphragm, we have gate valve, we have bulb valve, we have a knife valve, and we have a needle valve, punch, plug, and plug valves. All then up to the angle valve, which in 3 dimensions, we call it a 3-way divert. So like if you have a pipe in 3 ways, if you want to control your flow that is coming from, maybe you have a T, for example, you know what I mean by T? You have a flowing pipe, another one is coming to hook at the middle, then it will now become a T. So assuming the flow is coming from that point now, you want it to move in another way. There is a way the valve will rotate that will block the flow from moving to point C. What I mean is that if you have a flow line and you have another one suck into it, so the one that is coming into the main flow line, let's label it as A, then it comes to hook in that the horizontal one, then it becomes B, flowing like this, the other one up, which is B, C, A, B, C now. So the 3 ways now is for the angle valves to rotate. If the flow is coming from A, if you don't want it to go to B, the valve will now rotate and block C so that it will divert the flow to move down to C. So the next one, that is what we call a 3-way diverter valve. So which is the same thing as angle valve. So we have a pressure relief valve. So the pressure relief valve, they were there. The pressure relief valve is nothing but a valve that is there to safeguard your equipment from over-pressurized. You know, if there is a line, for example, if you have a flow line, a line carrying the gas at a high pressure, and you know, if there's a sudden increase in pressure above working what we call a maximum allowable working pressure of that line, you know, before you flow a fluid, allow a fluid to flow within within a pipe, for example, you need to size, you know, the size of the quantity of the fluid that is going to be flowing within the pipe within a period of time. So in that case now, as you size the line, you also size it with respect to the pressure it can withstand or it can carry. So above that one, it will now become a critical for that, lines, unbearable. So, and if there is no amendment or if there is no correction, if you allow such, that is the line, there is nothing like to take care of that line, like the pressure relief valve that is not there, for example, it is not there. If that line become a critical and that line is a gas line, then it will become an danger to that line, not only to that line, but also to the people living within that environment, because the catastrophe is bound to happen. Because if the pressure go beyond what the pipe can withstand, the next thing it's going to burst. And once it's burst, you know what is going to follow the gas, which is fire. So now the PRV, which is pressure relief valve, is there to relieve the excess pressure if it goes beyond what is meant for. So before you mount your PRV on those lines, you need to size the pressure relief valve so that above what we call MAWS, that is maximum allowable working pressure, WAMP, which is we call maximum allowable working pressure of that line. So that is how you size the pressure relief valve, so that when it sees above the pressure that line is rated, above what is rated for, then the next thing is going to open to relieve the excess pressure inside that line. So there were two. If you look at there are two. We have pressure relief valve and we also have pressure safety valve. They are the pressure relief valve and pressure safety valve. The two are meant from the root word safety. They were there as a safety guide to the equipment and at the same time to the flow lines to avoid being over pressurized. So one is set, your PSV is set to cease above. For example, if your line or equipment is rated saying the pressure of that equipment, for example, is 20 psi, you will now set your pressure relief valve that when you see above 20 pressure, for example, when it's usually above 20, say 21, you need to open. That means above 20, the PSV will start to work, because it is being configured that when you see above this pressure, open, so that above 1, I mean, even though if it is above by 0.1, 0.2, it will begin to open based on the set points. So that that is 0.1, 0.2, that is accumulating 0.3, 0.4. So it will now open gradually to relieve them. You understand? The PSV, I mean, yeah, the PRV in other way around is there. The first one, that is PSV, will open, I mean, gradually, that is PRV, but your PSV, when it goes beyond what the other one is open, slowly, 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 and the pressure keep on what accumulating to the extent that is now becoming critical. Your PSV, I mean, your PSV will just open. One is designed to open suddenly. That is a pop sound to relieve the excess pressure at once and come back to the normal operating pressure of that vessel or of the line. The other one will just be open gradually, gradually, gradually to relieve the excess pressure. So that is the major differences we serve as the yardstick between the pressure relief valve and the pressure safety valve. So at this point, let me pause for maybe a minute or two and let's hear your response. If there is any question, if there is no question, then we'll proceed.
Okay. If you have any question, you are free.
Just a minute or two, so that let's just know maybe you are flowing or
you are flowing with what has been said so far. Are you moving along the side, or there is a need to drawing back to something he has said? You want to draw it back to something he has said?
Waiting for the response, please.
Anything? Okay, maybe.
Are we together?
Are we together? Should we continue? Should we continue?
You can go ahead.
Okay. Before it goes ahead, in about 5 minutes time now, the Zoom, the time allocated is going to be exhausted. So when it's exhausted, just reconnect back. I hope you understand. Just reconnect back. We're going to come back online and just reconnect back. Okay. So we'll continue.
Yeah. Okay. That's PSV and PCV for you. So we also have some valves that we call them a control valve. So the control valve, they were there, they are being controlled with the help of an instrument. So what we mean by an instrument, yeah, we mean either electrically controlled. There is another, let me put it in such a way that you will understand. Just like another forces that will act on it, will dictate for that valve to operate. So the way it dictates, it can dictate in either electrically dictated to, give him a condition, electrically given the valve a condition to open or to close. It can also give information in form of a pneumatically controlled or hydraulically controlled the valve to open, that is command the valve to open or to close, and can be in data form. So that is those valves we call the control valves. So, but when we enter the P&ID improper, you will see the way the command is going to work. So the next one here is also the lines. So we have some line symbols. So these line symbols here, we have a major process line and we have a minor process line. So in our P&ID or in P&ID in general or PFD, the major process line is always in thick line than minor process line. Yeah. So I have a major process line there, major process line, which is a major process piping. So they are represented in thick line. So the minor instrument, the process line there are divided into, we have a major process line and we have a minor process line. So the minor, as in under the major, it's not on this piano, it's not on this legend sheet. So I'm just trying to add that on that. On the process line, we have a major process line and we have a minor process line. So others one, then the next one there will have a minor instrument piping. As I said, just like the way I said that we have a control valve that being commanding, the command that is given there, they are being given in form of what? Instrument. They are coming from the instrument to the what? To the piping, because those valves are situated along the pipe flow lines. So those valves now are mounted. So the command will be coming from the instruments on those control valves. So that is why I say that the command can either be electrical signal. So when the command is coming to that line, is represented as a broken line. And that is why you see it as what? Electrical signal there. So now we have a capillary, we have a software the data links, we have a mechanical links, we have a pneumatic signal, we have a hydraulic signal. So all those signals, by the time you see them going on top of those valves, for example, look at your pressure reducing internal sensors there. So if that line is coming, for example, if you have a broken line coming on top of those cap on that your pressure reducing now, then that line that is coming will now determine maybe that valve is under the action, is given an action from either electrical line or electrical signal. Is the signal an electrical or signal hydraulically or signal pneumatically? So when you turn to your P&ID, you will see all those things there. So now let's look at the small notes under it now. They said process line are colored. Key in what? In PFD and color key tables. So as we are going on, you understand it better. So the valve during the type operation is also, yeah.
Okay. Please, very soon, in less than a minute now, this Zoom is going to be over. So please get ready to connect back when it goes off, please.
So now, to move back to our left-hand side here, under the table here. So we'll have under the table, we have